Mike from MotoIQ here, and for this video we're going to talk about why Subaru engines blow up so easy. A lot of people have trouble with their Subaru engines, and I kind of tend to agree about that. I think the engines are pretty fragile, at least in turbocharged form. The naturally aspirated models, they can go for a long time, and you don't hear about them having too much trouble, but the turbocharged variants, like the STIs and WRXs, they pop their motors a lot. A lot of it is, almost everybody with a WRX or an STI builds their car, and there's all types of people that are qualified to build engines and tune them, and probably at least half of them aren't any good. When you have an engine that's marginally strong, it's really easy to push it over the edge. So let's look inside the Subaru engine, and I can tell you the kind of failures we see. Subaru guys are some of our best customers, and I think that's because a lot of them break their engines. The main thing we see are broken ringlands. Now this is a Subaru piston. Subarus have short strokes and really big bores. That's kind of good for high revs in some ways, but in the case of a Subaru, like you have a big bore, you have a lot of crevice volume, so for Subaru, they want to cut down their hydrocarbon emissions so they could pass the US's stringent smog requirements. When you have a big bore and you have your crevice volume, which is the space between the number one compression ring and the combustion chamber, that's an area where hydrocarbons can hang out. And believe it or not, that's a significant contributor to hydrocarbon emissions. So Subaru raises their number one compression ring as high as they can, the piston, to try to help with emissions. And this is fine for emissions, but it's bad for durability of a turbocharged motor. Now, you probably noticed that the dish of the piston is pretty big and it comes way out to the edge here, and the ring is really high. What that means is that you have a really fragile ringland. In fact, all the rings are pretty high on the piston, and they're pretty unsupported and thin. So the ringlands are fragile on the Subaru. So any detonation, especially with the stock hyperprotected piston, tends to either pinch the rings, kind of bend the ringland down a little, causes the ring to stick and you lose compression, or worse yet, like you break your ringland and you totally lose compression. Now this piston here, the rings are pretty stuck. It's subjected to some detonation because you can kind of see it as a sandpapered texture to it, so that's a sign of mild detonation. The ringland didn't actually break, but the ring is stuck, and that's what caused this engine to lose compression. For instance, if you want to compare it to an engine that has a reputation for being pretty strong, this is a Nissan SR20, and you can see how the rings are a lot lower on the piston than the Subaru. So the ringlands on the Nissan piston are a lot stronger. You can see how the bore is a lot smaller, and there's less room to trap hydrocarbons, so Nissan could get away with lowering the ring package. That's the number one reason. With a bigger bore too, the flame front takes longer to travel, so a Subaru engine has to run more advanced. So generally, you run a few degrees more advanced, especially when you tune them. Having to run more advanced, having a long flame front, that's gives the cylinder slightly more propensity to detonate. Detonation is death for these engines. If you look at the cylinder head, the combustion chamber geometry is actually not bad. It has a shallow included angle and has generous clinch pads. Now, shallow included angle has a low surface to volume ratio, and the clinch pads tend to produce turbulence to kind of squish the fuel-air mixture toward the plug, and it makes the fuel air mixture in the chamber turbulent as the piston comes to TDC. All of these things are good to prevent detonation. Now you have a good chamber, but for some reason, Subaru didn't line up any kind of quench pad on the piston with the quench pad on the combustion chamber. I think if they did that, like a lot of other engines do, you would actually have a more turbulent chamber and less propensity to detonate. But for some reason, Subaru has a good chamber design, but they didn't exploit it as much as they could to reduce possibilities of detonation. I would say that's the main reason why we see Subarus blow up. Now, a lot of people have problems with the head gaskets on these engines. And you could see, here's the engine case. Like the head gasket is not very well supported. Like it's an open deck engine, but you know, there's different open deck engines, and the Subaru is probably like the least supportive of the head gasket of, you know, just about any engine that's turbocharged from the factory. I mean, you can see that there isn't very much area for, you know, to get clamp on the head gasket. I mean, like here's the head gasket right here, and these black areas are kind of where the clamping pressure is, and it's mostly open space. You know, that's not too conducive for a good seal for a turbo motor. The other thing is that, you know, everything's pretty flimsy and can flex around. Like the turbo models, most of them have like these buttresses here. At least the EJ257 does. Some of the other ones don't have these buttresses, and that kind of keeps the cylinders from moving. The cylinders move, they work the head gasket, and there's more propensity for it to blow. So if we're building an engine that's going to run, you know, more than the low 400s for very long, like, you know, if it does track days or road race or time attack, we always do a closed deck conversion. So this part gets CNC machined out, and the close tolerance insert gets pressed in, and you know, that makes it act like a closed deck. This makes everything a lot more rigid, gives a lot more clamp area for the head gasket. Pretty good thing. Like if you're probably up to, you know, like 420, 430 horsepower, you don't need to do it, but I mean, it almost doesn't hurt. So the head gasket seal is one thing. Some people put studs in, but I'm not a proponent of putting a stud in a engine that's not going to be completely gone through, and we'll get into that in a little bit. The other thing that causes these engines to mess up a lot is the oil pump pickup. So the stock pickup is really flimsy. It's really thin metal. It's brazed together with like not much brazing material and not much fillets. So the pump pickup is actually prone to breaking. Now, I haven't seen a pump pickup break on a totally street-driven EJ motor, but people that do track days, I've seen several break. Even like kind of casual track days, I've seen them break. And even if you get a crack developing, the pickup will suck air and your engine won't get a good oil supply. Usually like it completely breaks off, and that's total destruction of your bottom end. So the pump pickup is not the way to go. So the way to get around the pump pickup breaking, IAG and Killer B both make excellent heavy-duty pickups. If you're going to be doing any track driving at all, or if you do like a lot of spirited driving in general, probably recommend one of these. They're not that expensive, and the cost of one of these things failing is pretty high. I mean, it's not like they all break, but I've seen a few break for no reason other than just being at high RPM and the vibrations and everything. So this guy is a cause of a lot of engine failures. The other thing that we see on track-driven and cars that are driven when cornering hard is these cars spit a lot of oil out of their breather system. And I mean, it's possible to spit so much oil like in a track session that your sump is starting to run low. And one of the reasons is that Subarus have very little crankcase volume. So you have these pistons going up and down, and as you can see, the crankcase volume is really low compared to like almost any other engine. So they run a lot of crankcase pressure, and this tends to blow a lot of oil up through the breather system. If you have a stock car and just drive on the street, you probably don't have too much of an issue. But if you have a tune and some bolt-on parts and you drive on the track, like probably most of you do, you are going to be spitting a lot of oil. And I mean, I've seen cars fill up 2 large catch cans in one session on the track. So, that's probably almost half the crankcase capacity. So a lot of these cars get run low on oil, and that causes bearing problems and, also leads to failure. Now, the other reason why they spit a lot of oil is this is a flat motor. So on most motors, when the oil comes from the top end and everything, it just drips straight down to the pan. On these engines, like the pan's down here, here's your crank. The oil kind of like is not dropping straight into the pan, but is kind of like making a 90-degree turn into the pan. Plus, if the oil's sloshing around, it's really easy to, under high G's, to slosh up and hit all these rotating parts, which causes a lot of windage, which causes a lot of oil to get spit out, especially when combined with the high crankcase pressure due to the small crankcase volume. Because of this, a lot of times the stock pan is inadequate. Now, the stock pan is actually not that bad. I mean, it has a couple of sets of baffles and everything, and it has a lower baffle that keeps oil around the pickup, and it has an upper one to prevent big slosh. But if you have like a track-driven one of these cars, and you have modified suspension and big sticky R compound tires and things like that, we prefer that you run a performance pan like a IAG or a Killer B with the pan baffles, the trap doors, and the windage tray. We really like the IAG windage tray because it actually has trap doors, so the oil can drop down to the pan, but it can't get splashed up into the crankcase area. But windage tray, baffled pan, higher capacity, it's all good stuff. Now the oil pump and all that is generally pretty good, and the oil capacity is pretty decent. It's fine for most use. But it's just the idiosyncrasies of the flat motor and the crankcase pressure all makes this perfect combination to puke oil out of the breathers. Puking a lot of oil out of the breathers, your sump gets low, your pickup sucks air, and there goes your bearings. The other thing that's important on these engines is to run a good air oil separator. Now, if you have a stock engine, you drive on the street, I mean, it's probably not necessary, but if you drive on the track and have sticky tires, modified suspension, if your engine's built, like let's say you have a full bolt-on car and a tune, I kind of feel like you need an air oil separator. The air oil separator will take get all your blow-by and all that stuff that's getting puked out. It'll separate that from the blow-by gas and put the oil back into your pan. So I think IAG makes a really good air oil separator, so does Killer Bee. A couple other people make catch cans, but I think Subarus tend to puke so much oil that you don't want a catch can. You want that oil to get back in your crankcase. So I recommend the AOS. Now, if your car is purely track driven, I think the Killer Bee one is nice and simple and will return the oil to your crankcase quickly because it has like this kind of a funnel shape. Now, if you do a lot of short hop driving and if you live where it's cold, I think the IAG air oil separator is better because it circulates coolant through the can part of the separator so you don't get that milkshake watery oil going back into your pan. So heavy duty pickup, a good pan with baffles and a windage tray will help a lot to prevent your Subaru from blowing up. When you look at the crankshaft, this is kind of one part of the Subaru engine I think is actually not that bad. The crankshaft is short, it's pretty stiff, it has pretty decent journal overlap. The stock crank actually gives very little problems. We like to run the post 2006 OEM crank. That has like, it's nitrided, so the journals are really hard, wears real well. The stock crank is good for like maybe 700 horsepower easy, and it hardly ever gives problems. So your stock crank is one part of this motor that Subaru did a pretty good job and you shouldn't have issues with. Now, the case is a whole nother deal. Now, the cases on the Subaru don't weigh that much. There's not that much aluminum, not that much reinforcement. So you're asking this thin, flimsy aluminum thing to handle a lot of pressure and a lot of violence going on in there, and it's kind of not up to the snuff. Now, if you're serious about doing time attack and you're pushing this motor for all it's worth, I mean, a lot of guys will disagree with me, but my opinion is that you go much past the mid 500s, you get away from the happy zone of the EJ motor no matter what you do to it. I mean, sure, you can make 800, 1,000 horsepower, but those are more drag racing motors. If you try to run that level of power on something like that sees road racing use or track days, you're going to be going through some motors. Now, you might not have like a catastrophic dramatic failure, but you're going to be going through motors and having to maintenance them a lot and tear down an inspection, stuff like that. I mean, they're going to be more finicky than just about anything else. And a lot of it is just this engine wasn't designed to take those kind of power levels. I mean, there isn't much to it. Like, there isn't much metal and much reinforcement to take all of that. So this whole case and everything flexes around. I mean, you could close deck it and you run studs and all that, but still, I mean, you can only, you can't make a pig's ear a silk purse no matter what you do to it. I mean, some of the things we do is, of course, I talked about closed decking. We'll also bore the holes out, and then we'll run 12 millimeter ARP studs. If you're getting much above 500 horsepower, we'll actually dowel pin the mains here. That kind of keeps it from flexing and getting misalignment down there while the engine's at full song and killing your bearings. But even doing all of that, the engine's not like bulletproof or anything. It's not like a Honda K motor where you have like that whole bottom end girdle deal going on. So it's going to flex. You're going to have bearing problems. You get two bad bearing problems. really bad things happen. So I think the important thing is to have realistic goals. Sure, you can make 800 horsepower and have a lot of fun, but you're not going to be doing it for long in like a road racing kind of situation. If you want to have your 800 horsepower time attack car, better bring a couple of motors in the trailer, before you go cross country to Coda or Super Lap Battle or something. I'm just being realistic, and that's what you can expect. I mean, you can make these things so they'll pretty much run at 550 for a good long time, but more than that gets kind of sketchy. I think like another thing is these engines are actually fairly difficult to build, and that's another reason why they get such a bad reputation. It's not like they're difficult to assemble, but there's like a lot of quirks to them that if you're not experienced with Subarus, you're going to have trouble. One of them is that when you bolt the head and you bolt the case halves together, there's everything's so flimsy that there's a lot of distortion. So when you machine these blocks, you have to have a bottom plate and a top torque plate. And if you're running studs, you actually have to pre-machine it for studs and torque everything to the stud torque spec before you bore the block. This is because, if you actually measure one of these things, when you bolt it all up with studs, I mean, you can easily get 1.5 distortion in the cylinders. And if you bore it with without the plates, when you unbolt it, you'll have all this distortion. And even if you run forged pistons, that's half your piston to wall clearance is taken up by distortion. I mean, if you have if you just have your machine shop bore out your block or your case and slap it together, and you're running the hypereutectic pistons that run pretty tight clearances, I mean, your engine could seize and get wiped out because the distortion can be the entire piston to wall clearance. The other thing is when you stud everything and torque it down, it distorts the bottom end. So, a lot of guys might slap studs in there, torque everything down, and then the crank doesn't turn anymore because it's so distorted that the crank is actually getting pinched. That's why some other YouTube channels that have tried to build Subaru engines have blown them up in short order. It's not like they don't know what they're doing. They probably just don't know the idiosyncrasies of a Subaru. So when we machine the Subaru, we do all the boring in the fixture that simulates the whole engine being bolted together. If we're going to run studs, we put the studs in and run at the torque that the studs are going to be at. So all the distortion gets in there. Then we do all our bore machining, and then when the engine's together, you'll have nice straight round bores. The other thing is if you're running studs, we always align bore the cases. So that's shaving a little bit off and then running a line hone through there. And these things require line boring more than any engine I've ever seen, actually. So if you're running studs, 100%, you're going to need to line bore it. And for sure, you need the fixturing. That's a big idiosyncrasy, and that's probably why a lot of you have probably heard, don't try to build your Subaru engine, just get a factory long block, because the factory is the only one that knows how to build the engines. And that's not exactly true, but if you, machine everything properly, your chances of success go way up. So I would say improper machining is the biggest cause for built engine failure. If this is all intimidating, make sure your cases get machined by a Subaru specialist. You can buy pre-machined cases from IAG. Their cases are good, or Out Front Motorsports. They have pre-machined cases. You can get them with the stud holes all machined and closed deck conversion and your bore and your line bar all ready to go. The other thing that happens is that Subarus have a lot of deck surfaces. So in your regular engine, if you're going through it and you want to clean up the deck of your head and clean up the deck of your block, you take maybe 5/1000ths cut on both, and so your engine gets about 10/1000ths shorter. So your cam timing only gets off maybe a little bit, but on your Subaru, you have your case. If you align board, like you take some off of here, you take some off of here, you deck the case, you take some off of here on both sides, take some off of both heads. So what happens is all those tolerances stack up, and your far cylinder, your cam timing can be really off by the time you get there. So when you're assembling a Subaru that you've built and everything's fresh, it's imperative that you actually degree in your cams and actually see where your cam timing's at, because your far cylinder head, there's a good chance that it's actually running pretty retarded in the cam timing. Now, they make adjustable timing gears. They also make offset keys, especially for Subarus, so you can compensate for some of that machining change. But, just don't slap your Subaru engine together. Measure every single thing. Degree in your cam with a degree wheel. Make sure that, especially the far cylinder, your cam timing isn't like super retarded, and you'll be fine. We also get like guys that want us to build like a naturally aspirated Subaru that'll rev to $9,000, and they think they'll compete with Honda K motors or something, but that's not going to happen, and there's a few reasons for that. The number one thing is the Subaru head doesn't flow anywhere near a Honda K series. Like the intake ports are pretty decent, pretty good geometry, pretty good short side radius, pretty good shot into the cylinder. But when you go to the exhaust side, the whole exhaust flange is offset. So that means that the front cylinder, the exhaust port goes through a big dog leg, which really kills the flow to that cylinder. And it's really hard to get both cylinders to flow equally across the lift curve. In fact, it's impossible. So even the finest CNC heads aren't gonna flow anywhere near a K motor. The other thing is the Subaru has a shim and bucket valve train. So that's kind of good because it's light, doesn't have mass, so you can get away with not running as heavy spring and not getting valve float. But the problem is that if you put a radical cam grind with a lot of area under the curve, the lobe will run off the edge of the follower. So you can notch the head to make some clearance, but you can only get so radical with the cam before the lobe runs off the edge. And if that happens, it wipes everything out, or everything wears super quick. So you're limited in what kind of valve events you can have. Also, the Honda uses finger followers, and with the finger follower and the roller, you can get, well, not a roller, but with a finger follower, the leverage ratios and everything allow you to have valve events that you can't get on the direct acting, what do you call, like shim and bucket. So like the Honda, you can get way more area under the lift curve and way more radical valve events. So, like we always tell people, don't try to build the 9,000 RPM EJ because you're going to be disappointed. The other thing is there's not as much NA development done on EJs, so they don't have like cams that have been researched out as much. And even if somebody did try, you're limited by the basic design of the valve train. So, I don't know. In our opinion, don't try to build the killer NA EJ. A lot of people have asked us to, but I always tell them you're going to spend a lot of money and you're going to be disappointed. The other thing is when you go NA, you go high revs and big power, the power band gets more and more narrow and higher. So if you have your stock wide ratio transmission, you're going to be falling out of your power band in between shifts, and that's going to suck. So I don't know, my opinion for big power, this engine wasn't meant to be NA. It's best boosted, but it's fragile under boost. So, tailor your expectations. Sure, there's a lot of guys making 800 horsepower, but they're either hooning on the street with an occasional blast down the freeway and an occasional pull on the drag strip. That's not like doing a track day. Like let's say you just do a fun track day, not competitive. Let's say you do 3 sessions. I mean, you're on it for 20 minutes at a time. I don't even know how many quarter mile passes that is or how many freeway pulls, but in one session, you'll probably drive your car harder than a lot of these 800 horsepower guys driving a whole year. So tailor your expectations and don't overdo things. Now, I think relief is coming though. Like IAG is currently developing a fairly affordable case. Now, like there's billet cases for these engines, but a lot of times I feel like a billet case isn't necessarily that great for the street. Most of it is because billet case is pure solid aluminum billet, and the area around your main bearings kind of grows with heat in that respect, and it's kind of often it's hard for the stock oiling system to maintain oil pressure at low RPM, for instance, because your main clearances grow with heat. So you might have really low idling oil pressure. If you have a dry sump that cures everything, like a full race motor. But you got to be careful about those full billet blocks. They're strong, but sometimes you have to consider things like that. But IAG is coming out with a new cast case that's going to be super heavy duty. So it's going to have a lot thicker of a deck. It's going to have thicker cylinders. It's going to be closed deck. It's going to have a lot more beef around the main area and a lot more support around the crank. It's also going to have priority mains. So that means that the oil pump is going to feed the main bearings first, and then the surplus oil is going to go to the top end. So your mains have a better chance of getting good solid oil all the time. The most important thing is it's going to have cast-in steel inserts around all the main bearings, just like an OEM block, and this will control the expansion around the mains, so you don't have the growth and you don't have your clearances opening up with heat. So it's going to be like a stock block, but it's going to be way stronger. They're addressing all the weak points of the stock Subaru. It's going to have 12 millimeter studs. It's going to not be a elaborate CNC billet piece, so the price will probably be like half of what a billet case is. So stay tuned. I think IAG is going to come out with that probably in the next 6 months. I could be wrong, but I know they're deep into the development process, and I think that's going to be a game changer for the Subaru people. That way you'll be able to make 800 horsepower and have the engine live, and everything will be happy. But that's coming in the future. These are the reasons why I think Subaru engines kind of suck, but you keep it stock, it'll probably be happy, but you start playing with it, things are going to happen. The last thing before I stop is when you mod these engines, there's a lot of like local shops or whatever that maybe they don't know Subarus really well, or they're one pull hero kind of tuners. So they do one pull on the dyno and send you on your way. You don't want to do that with a Subaru. You want to be conservative, tune conservatively, keep your air-fuel ratio slightly rich, keep your timing slightly retarded, keep your boost slightly lower. When you're going on the track, run a few gallons of race gas. Tune for your worst case. Make sure that you have good cooling. Watch our last video on 3 ways not to have your engine blow up, and then do that. And I think you'll be a happy Subaru owner. Now the rest of the car is pretty good. You just got to watch that engine. So, follow our advice, manage your expectations, and you'll have fun with your EJ. So until next time, check us out at MotoIQ.com. We have a ton of Subaru build articles. Check our YouTube channel, subscribe. We have a lot of Subaru content there. If you want to build your Subaru, check out our web store. We have like most of the parts we talk about. If you want to get some cool merch, like we have hoodies, we have t-shirts. If you don't like the giant MotoIQ emblem, we have some other cool ones too. Support us, and they'll help us come out with more content. So until next time, have fun out there and don't blow your stuff up.